What's happening, dogs? Mr. Allen here, simplifying some exponential expressions in this video. So we're going to be busting out those 5 different exponent properties and using them throughout. Now, if you don't remember your exponent properties or you need a little refresher, make sure you check out my exponent properties video. I'm going to link it. I believe it goes right up in this corner here, or perhaps it's this corner. I can't remember. Either way, click that, watch it, or let's get rocking and rolling with these if you're good with those properties. So the first one here, I have 3x squared y to the 4th. Nothing out here, so that's just going to stay. It's multiplication. But this guy here is raised to the 0 power. What's anything raised to the 0 power? It's not 0, it's 1. All right, anything raised to the 0 power is 1. So this is just going to go away. It's going to become 1. And then I'd have 3x squared y to the 4th. If you do want to think about like what's going to really happen, times 1, it's just that, right? So we have 3x squared y to the 4th. Boom. That's it. That's it for that one. It's like, feels like a freebie. Now, if you're wondering right now, you're like, why is anything to the 0 power 1, right? Why is it not 0? I'm going to do a little informal proof for you guys, okay? A little street math, if you will, off to the side right here, okay? So we said anything to the 0 power is 1. Well, if I had, say, like x cubed over x cubed, and I use my exponent properties, I'm subtracting my exponents when I'm dividing like bases, I get x to the 0 power, right? Okay. Well, what's anything divided by itself? It's 1. So I'm saying that x to the 0 equals 1. Now, if you're like, that's not a real proof there, Mr. Allen. Far too informal, right? Wait. Like I said, we're doing a little street math here, but I'll formalize it a little bit for you. If I had x to the n over x to the n equals n minus n is 0, so I'd have x to the 0, and anything divided by itself is 1, where n is some number as well as x being some number. However, there's a little mathematical uncertainty / beef, if you will, or arguments over 0 to the 0 power, right? Some people say it's 1, some people say it's undefined. I'm not even gonna mess with that, man. Okay, I don't want people coming at me. I don't know what that is. Okay, nobody does. It's either 1 or it's undefined or whatever. That's enough of that mathematical sidebar. There you go. Let's move on to this one over here. All right. So we got 2x squared y to the 4th, all raised to the 3rd power. And then I have 4x to the 8th, y to the negative 3rd, all raised to the negative 1st power. How am I going to address this? First off, I'm going to get rid of this right here because it's in my face. Okay, it's in my face right now, so I'm going to erase it. And so here's how I am going to go through this particular problem here. And there's multiple ways to do it, which is part of the confusion with exponents. Even though there's only 5 properties, it's easy to get a little bit lost. I'm going to rewrite this where this guy here, which is all raised to a negative power, is moved to my denominator, okay? And to save a little bit of space, let's just do this. I'm going to write this, we were doing some street math earlier. Why not continue with the street math? Negative 3, and that's all raised to the 1st power now. And then this guy, this is just gone, okay? I rewrote it down there. Cool? So now I have a fraction, and I've got positive exponents outside of my parentheses. How are we going to address that? Well, I'm going to distribute this 3 as an exponent into that set of parentheses there, and it's going to get distributed to all those powers. This is 2 to the 1st power. It's going to get that 3, right? I cannot distribute an exponent into a sum or difference like x plus 5 to the 3rd power. I can't distribute that in. I'd have to multiply it out 3 times, okay? But when it's all multiplication or division, I can distribute my exponent to my exponents. So I'm going to have 2 cubed, so 2 to the 3rd, and then I'll have 2 times 3, that's 6, right? Power to a power rule says we're going to multiply my exponents. So I'll have x to the 6th power, and then 4 times 3 is 12, so y to the 12th power. Down here, it's all raised to the 1st, so nothing's going to change. It's just going to be 4. Then we have x to the 8th and y to the negative 3rd. All right, now we can start to clean some things up. I know that 2 to the 3rd power, that is 8. Okay, so I'm just going to rewrite that as an 8 right there. Okay, and now I can do some simplifications. So for 8 divided by 4, that's just 2. That's a common mistake. When people start working through exponent properties, they're like, oh, with division, I subtract. No, with division, you don't subtract. With division of like bases, you subtract the exponents, right? Big old numbers, coefficients, they still work the same. The math still holds. 8 divided by 4 is 2. It's not 4. We're not going to subtract. There's not new math coming here. It's just properties of exponents we tend to apply inappropriately, right? You don't want to do things that are inappropriate in math. Lands you in math jail. So now I have x to the 6th over x to the 8th. Here's how I like to think about it. I look at the bigger exponents. 8. 8 minus 6 is 2, but where was my bigger exponent? In the denominator. X squared goes in the denominator. Boom. Last one, I got 12 and negative 3. Bigger exponent is 12. 12 minus negative 3 is 12 plus 3, right? 12 minus negative 3, that's plus 3. I get 15. Where was my bigger exponent? It was in the numerator, so I get y to the 15th in my numerator. Do I have all positive exponents? Are all simplifications of coefficients done? Yes, this is my final answer. It's dope. All right, let's go green on this one. So I've got a fraction all raised to the exponent of 2. And like I said before, there are a couple ways to do this. This is how I'm going to go about it. I like to simplify anything I can inside. Then I'm going to distribute my exponent of 2. Could you distribute that exponent of 2 first? Absolutely. Numbers are going to get a little bigger. Then you got to clean up more. I like to clean up the inside first, then work to the outside. All right. So for this one, let's clean up the inside. Let's see here. 4 over 10, make one big old fraction. I can divide those both by 2, so I get 2/5. X to the 9th, x squared, bigger exponents up here in the numerator. 9 minus 2 is 7, so we get x to the 7th in the numerator. And then I have y to the 1st and y to the 5th. 5 is the larger one. 5 minus 1 is 4. Larger one's in the denominator, so y to the 4th. Close it, it's all squared. Cool. So now I have less to distribute this to. It's going to go here, here, and then it's all whoop, there, and there. And keep in mind, the 2 and the 5 both have an exponent of 1 there. The 2 doesn't, it doesn't multiply to this 2 or multiply to that. It's not going to be 4 over 10 again. It's 2 squared and 5 squared, okay? Another common error, okay? So the exponent, although we multiply to the exponents, you don't multiply to the coefficients, okay? So we get 2 squared, which is 4. I'll write it as 2 squared for now. 2 squared, then 7 squared, x to the 7th squared. We'd multiply 7 and 2 to get it 14. And then down here we have 5 squared, and we have y to the 4th squared, so 4 times 2 is 8. And then let's get our final answer here. 2 squared is 4. You could have done this all in the one step. X to the 14th over 25, y to the 8th. Boom. All right, next one here. Although this looks like it's the same color as the green, it's not. This is neon yellow versus neon green. They are different. They just appear very similar on the board. Unfortunately. Whatever. I'm going to switch to it, though. Oh, boy. A negative exponent on the outside. Okay. To change that negative exponent on the outside to a positive, I can flip the inside. However, just like before, I would highly suggest cleaning up the inside first. Okay? If there's nothing to clean up, flip it right away. One thing to note, when you do flip it, everything stays the same. It's just flipped. So like that y to the negative 5th would have stayed y to the negative 5th, but it's just in the numerator, okay? So negative exponents don't change if you're dealing with it from out here, all right? So I'm going to clean it up, though. Just like I said, just like we did here, I'm going to clean it up first. 9 over 3, one fraction here. That's going to give me 3. Let's see here. 10, this is 1. I've got, let's see, 10 over 1. Why am I... 9. 10 minus 1 is 9, so we get x to the 9th. And then 4 minus negative 5 is y to the 9th. Still the negative 3rd. Is there anything left in the denominator? No, nothing. But because this is a negative exponent, I'm going to leave a 1 down there because now I'm going to flip it, and that negative 3 changes to a positive 3. So it kind of helps to have had that fraction there, throw a 1, and now I'm going to have 1 over 3x to the 9th, y to the 9th, to the positive 3rd, okay? Inside flips, outside exponent changes to a positive. Cool? And then last but not least, let's go ahead and distribute this in. I'm going to have 1 cubed, which is 1. 3 cubed, because it's 3 to the 1st, cubed. 3 cubed is 27. Then I have 9 times 3, that's 27. Ooh, this is fun. Didn't plan this. 9 times 3, that's 27 as well. A lot of 27s. 27. That was my football number back in the, the Junior Trojans days. All right. There we go. Beautiful. Awesome. All right. So key points here, guys. Power to a power. I'm multiplying my exponents. But don't then say that I have to multiply like 2 times 2 or 5 times 2, right? It's 5 to the first squared. The 1, the exponent of 1, is getting multiplied to that 2, right? Dividing with like bases, we subtract our exponents. But that doesn't mean that we're subtracting coefficients. It's 8 divided by 4 is 2, okay? Common mistakes that occur in exponents. It takes some practice. Practice makes perfect. Thank you guys for watching. You are awesome. If you have any questions, let me know. Pop it in the comments. If you want another video, you're like, hey, can you make one like this? Or do you have one like this? Let me know. Happy to do it for you guys. Have a great day.